just kind of get us back to where we were from Friday. All right? And so what is our rule on this first one right here? What are we going to do? We're going to multiply the exponents. This is a normal number, so that's 2 squared, which is going to give me 4. I'll change it in a minute. It's going to be x to the 4th, and it's going to be y to the negative 6. Okay? So this is going to be 4. X to the 4 is going to be with it, and then we're going to fix the negative 6. We're going to put it on bottom, and so there's what we should have gotten on that one. Okay? Everybody okay there? So that was page 398. That's kind of what we did on page 398. All right? The next one. This was what we did on page 400. Okay? We want to rewrite it probably in radical form first. What number is going to go here? 3. The denominator goes there. We're going to put that there. You could put the 2 there if you'd like. Most of the times I'm going to put it on the outside because I want to do the breakdown first before I build it back up. The cube root of 8. 2. 2 times 2 times 2 to get 8. So in the parentheses is where 2. Square it now. So my answer is going to be 4. Okay? So that answer would be 4. Now, if you squared 8, you would have gotten 64, and you could do the cube root of 64. That's fine. But that's one that we don't know probably as well. It is 4. Okay? On this last one, we simplified for those two, and we solved for this one. In order to solve, what has to be true?
2 to x plus 1 has to equal 8.
Yeah, that's got to be equal to that. But in order to do that, we want to have like bases. And right now, we don't have like bases. So I'm going to start with the 8. How can I do that?
2 cubed.
2 cubed. That's 2 cubed. This is x plus 1. Now I have the bases to be the same. Now I have x plus 1 equals 3. Subtract 1, and x is equal to 2. Okay, so that was page 401. So just kind of getting you back up to speed where we were on Friday. Everybody good? All right. Today what we're going to discuss is we're going to talk about graphing. All right? So we're going to graph exponential functions. All right. So the first thing that I want to talk about is when we graph, it's going to be in the format of f of x equals b to the x. So we have a base, and we're going to raise it to an exponent x. All right. There's a couple things that have to be true about the base. The base has to be greater than 0, and the base cannot equal to 1. Right? The base has to be greater than 0, and the base cannot equal to negative 1. And somebody give me a reason why one of those is true. Why do I have to be bigger than 0, and why can't that be equal to 1? Say again? If it's just 1, then it's 1 times 1 times 1 times 1, so it's not exponential. It would be what? It'd be linear. It'd be a 1. It'd be whatever it is. All right, y equals 1. It'd be the same. So that hadn't changed. So that's kind of a boring linear graph. All right. Why does it have to be greater than 0? Why does it have to be positive? Let's say it was negative 2. If I did this right here, these would be my first ones. What kind of number is negative 2 to the first power? A negative number. What happens when I square negative 2?
Positive.
Positive. When I cube negative 2? Negative. So if I don't have a number bigger than 0, then I'm going to go from a positive number to a negative number to a positive number to that graph's just going to yo-yo back and forth. All right? It's not going to be a nice steady graph. So we want positive bases, all right? And we don't want 1. Now, if b is bigger than 1, then it is going to increase. If I multiply by a number bigger than 1, it's going to get bigger. We refer to it as an exponential what? Growth. That's correct. Okay? That's an exponential growth graph if it's increasing. Now, if we have the base, if the base is between 0 and 1, it's positive, but it's like a half. It's like 0.8, all right? It's 1/3. It's a positive number, but it's a fraction or decimal. Then it's going to decrease, and that's an exponential decay. Okay. So just a couple of things for an exponential. It's got to have a couple little stipulations on it. It can't just be anything, right? Because we want this nice continuous growth graph or decay graph. Okay? All right. Am I all right with those? All right. So let's graph one. The first one that I want to graph with you is I want to graph f of x equals 3 to the x. That's the first one we're going to do. Okay? F of x equals 3x. And you just kind of sketch it the best you can on here. That's fine. All right? Is that going to be a growth graph or a decay graph? Growth. It's going to be growth because the b value is bigger than 1. So this should be an exponential to growth. Okay? Now, on this first one, I'm going to build a table. I'm not going to build a table outside of this. I'm going to just build it for the first one. What would be some good x values? What would be some good exponents I could plug in over there that I would know very quickly? 0, 1, 2, 3. I agree with that. Probably want to do a little bit of negative. Someone probably got to do -1, -2, -3 as well. Okay? So that would be a pretty good little spectrum of numbers I can use to test this. All right? I'm going to start with 0. 3 to the 0 power is 1. Anything to the 0 power is 1. Okay? If I put the exponent of 1 up there, what do I get? 3. 3 to the first power is 3. 3 to the second power is 9. Thank you. No 6s there. All right? 3 cubed is 27. Okay? Now, if I were, by the way, probably not going to graph that one. That's a pretty good sized number. Okay? If I go the other way, if I put 3 to the -1, what does a negative exponent do? Makes it into a fraction. Takes the 3 and puts the, it's going to be the same as this 3, but it's going to take that 3 and going to put it in the bottom. So 1 over 3. So 3 to the -2 is going to be 9, but it's going to be 9 in the other spot. It's going to be in the bottom. So 1/9 and 1/27. Okay? Now, if I were to go graph those, I got 0, 1, I've got 1, 9, I've got 1, 3, 2, 9, 3, 27 is not going to fit, -1, -1, 1/3, -2, 1/9, -3, 1/27. So my graph looks like this. That is an exponential growth graph. So when it talks about characteristics, that's what I was going to put down there, exponential growth. What's the domain? All real numbers.
Greater than 0.
Still going up, right? All real numbers. Is there any number that I can't put for an exponent? We've put positive numbers, we've put negative numbers, we put fractions the other day. All right, so we could do all these. So all real numbers work for the domain. It goes forever left, forever right. Okay? How about the range? Y is greater than 0. That's correct. Y is greater than 0. And if you notice here, it's leveling off. So it does have an asymptote here. It's an asymptotic graph. What kind of asymptote does it have? Horizontal asymptote, and it is at 0. Okay? Got a horizontal asymptote at 0. Now why? Well, if I kept this going, if I kept the 1 over whatever going, the next one will be 1 over 81, the next one will be 1 over 243, the next one will be 1 over 729, all right? Next one will be 1 over 2187, all right? And so I've got 1 out of a really big number. It's going to continue to get bigger, all right? And so will that ever be worth 0? No. It's going to be really close. That's that whole idea why people play the lottery. I got that 1 out of a million chance, all right? So I'm going to be that one guy. I'm going to win that lottery. 1 out of a million. It's not 0, right? Huh?
That's definitely how logic works.
Yes, exactly. That's how a lot of people think. I'm going to be that one person, All right. If it was 0 out of a million, nobody would play the lottery.
I would play. That would be fun.
0 out of a million?
That
Where
would
you couldn't win at all? I don't know about that. All right. So I have that. Now, on this, on the next, from the next page here on, I'm going to only work with 2 points. The 2 points that I'm going to focus on are going to be these 2 points right there. Those are going to be the 2 easiest points on here. Got a couple of side conversations. So when we do graphing functions, all the graphs are going to go through 0, 1. So that's a really easy point to get. And they're going to go through 1 and the base, whatever the base is. The base happened to be 3 in this last one, so we used 1, 3. But whatever base that I have, it's going to go through that. Okay? So when I get my points from here on, I'm not going to do a whole table. I'm just going to use those 2. Okay? So let's try another one. The next function I want to graph is I'm going to graph f of x equals 1/3 x. So I'm going to graph that one right there. F of x equals 1/3 x. By looking at it, it's going to be a what? Decay graph. Why is it decay? This is less than 1. The 1/3 is less than 1, so it's going to be an exponential decay. It's going to work downward from left to right. Okay? The 2 points that I'm going to use are going to be 0, 1, and 1 and the base, which is 1/3. Now, some of you don't like that. Don't like the 1/3 as a point. All right? Could I get the 3 to be back on top? Instead of being 1/3, could I get it to be 3? How would I do that? With a negative exponent. So the third point made that you might use might be negative 1, 3. That would be a good one. Because if I flipped it, that's an easier point to graph than maybe 1 and 1/3. Okay? So I have 0, 1. I have 1 and 1/3. Or if you flipped it and went negative 1 and 3, there's 3 pretty good points for my graph. I need to see at least 2 points on your graph. Anytime you're sketching, 2 points. Has an asymptote. It's got an asymptote at 0. And it's got these points right there. So I didn't go build the whole table all over again. Okay? Domain for this. Again, all real numbers. Okay? Did my graph change as far as the range is concerned? No. Nope, still y is greater than 0. My asymptote is still y equals 0. It is a decay graph. Okay? Everybody all right so far? All right. There's one other concept I want to put in here real quick. All right. We talked a little bit about it last year in Algebra 2. All right. We talked about the base of E. All right. So if I have a base E, so I have a base of 3, I have a base of 1/3, and if I were to use a base of E, okay? So if I use base E, there was a certain condition where we used base E. Anybody remember when we used base E with exponential?
Always reoccurring.
When it's always reoccurring, okay? So this is a compounding problem. We're going to talk about compounding problems a little bit later in the week, all right? And so when I continuously compound something, when I have a continuous situation when something's happening over and over and over again, then I'm going to use the base E, okay? Now, I'm going to do this one in the calculator with you real quick, kind of fill in this table, all right? So this is what this is saying. This is 1, everything that you have right now, all 100%, plus we're gonna grow it by 100%. So basically we're doubling it, all right? So when you grow something by 100%, you're doubling it. Compounded how frequently? So the 1's gonna stand for like 1 year. I'm gonna compound it 1 time in a year. 2 would be twice a year. So once in the summer, once in December. 5 times a year, 10 times a year, 100 times a year, so forth. And I want to look and see what this is doing as we're doing it. Okay? So I'm going to put that, I'm going to help you put that in the calculator. So grab your calculator real quick.
Dad, your calculator's in Chinese.
All right. Go grab the calculator real quick. Go grab the calculator. I'll fix it later. All right. So I'm going to go add a graph. In that graph, I'm going to put a parenthesis. I'm going to put a 1. I'm going to put plus. Controlled division. 1 over x. And I'm going to raise that to the x. Okay? Okay? So it would probably be good if you started fresh with this. I know it would probably be in from last class. All right? So I have that. And if you hit enter, all right, you get this graph right here. Now, what does this graph kind of look like? I know. Two units ago, we did some of these. It looks like rational, all right? 1 over x, that's the rational, but it's got an exponent in it as well, so it's got some exponential also in it, okay? Now, here's what I want to do. This is the key that I want you to see. We're filling that in that table, all right? So if I were to compound this 1 time a year, I'm going to go menu, I'm going to go trace. So if I go menu and trace, graph trace, then I can type in whatever x that I want to type in. The first x I want is I want to put a 1 in. When I put a 1 in, I get 2. So if I was filling in that table, 1 compounding would give me 2. All I have to do to do the next one is I'm going to type a 2 in. If I type 2 in, then I get 2.25. So 1 compounding is 2, 2 compounding is 2.25. If I went to 5 compoundings, that would be 2.49. If I did 10, that gives me 2.59. If I went 100, then that would give me 2.7. All right. If I went to 1,000, it gives me 2.72. By the way, are you noticing anything about where I am on the graph? What's the graph look like right now? It looks like it's like an asymptote. It looks like it flattened out, correct?
Yeah, it's staying.
So as I continue to go to infinity, my number is going to stay the same. My number is going to stay at 2.72 in the graph. All right? So we'll continue through it. And so basically what we've done here is we've created this continuous idea. The 100 was like 3 times a year, like every 3rd day. If I did 1,000, that's like 3 times a day. All right? So it's like I'm doing this over and over and over again. And so what we discover on this is that we create this idea of E, and that levels off at that 2.72. A little bit more accurate is 2.718. Okay, so if we could round, that's the thing that you need on this page. You need to know that E is equal to 2.718. That's what you need. If I told you pi, what would you tell me? 3.14. This is a number just like pi. It's got little different values and characteristics, but it's an irrational number that goes on and on forever, but it describes continuous compounding, continuous situations, and E is 2.718. Okay? Now, why did I go through all that? I want you to see where it came from, for one thing, all right? That this is just not made up, all right? The other thing is this. Again, you don't have to copy all that up there. You just need the E is equal to 2.718, all right? Is what happens when I ask this question right here? All right? I want you to graph f of x equals e to the x. All right? I want to graph f of x equals e to the x. Well, first of all, is it growth or is it decay? It's growth, because why? 2.718 is bigger than 1. Okay? Now, what are my 2 points on this graph? 0, 1, it's always gonna be 0, 1.
And then 2.7.
And then 1 and E, which is 2.718. Okay? Now, how are you gonna grade that? Because it's a decimal. Well, 0, 1 is here. And as long as you do 1 and you put me a point somewhere between 2 and 3, then I'll be good with that. Okay? Still has the same asymptote. Still looks almost exactly the same. Alright? My domain is still all real numbers. My range is y is greater than 0. My asymptote is still the same. So don't get confused. Don't get worried because now I don't have a number there. Okay? I don't have a 1/3 or a 3 or a 2. Alright? I've got an E, but I know the value of E is 2.718. I can keep going.
How did they define the value?
I think somebody was probably messing with compounding, maybe some interest or something like that, and said, what if we just kept doing this over and over and over again? And then notice that it kind of leveled off. Okay. The E, I know it's very original. The guy that discovered this, his name is Euler, E-U-L-E-R. So they used his last name, I guess, to use E. He gets credit for it. So that's the guy. You can go look that up. That might be an IA situation. Okay? All right. Now, let's do this. Now that we've graphed a couple parent functions, we need to go be able to transform and move these exponential graphs around. Okay? So, I have f of x equals c times 2a to the x plus or minus b, and then plus d. In an exponential function, where are the parentheses? Where's inside the function? Everything inside the exponent is inside the parentheses or inside the function. Okay? So with that, how is this graph moving? Give me a letter and tell me how that moves my graph. How's my graph going to move? A, B, C, or D? Give me one of them. Tell me how.
It's like the vertical reflection.
Okay.
Right?
Good. C would be my vertical reflection and stretch or compression. So that I'm going to name that dilation, just so that it includes both of them. Okay. So that's good. Very nice. C is not in the parentheses. It's on the outside. So C is going to be my vertical reflection or my vertical dilation. Good. D is the up and down. Good. All right. So D is going to be up and down. Now, there's something else that's tied to this. That's going to be my horizontal asymptote. The D is going to control the horizontal asymptote. So if I slide it up and down, that's what's going to take place there. Okay? Bless you. All right. Next. What else do we know?
A is the horizontal dilation.
Okay, good. A is going to be the horizontal dilation or reflection. And then B is going to be the left and the right.
Would that be your vertical asymptote?
Well, this one doesn't have a vertical asymptote, but you're kind of getting ahead of the game a little bit when we talk about log graphs. Log graphs will have a vertical asymptote, so the B would change the asymptote now. But that's a couple days from now. All right. All right. Good. All right. So let's try a couple of these. By the way, nobody said anything about the 2. What's the 2? The 2 is my parent function. That's where I'm going to get my 2 points from. In this case, I would use 0, 1, and 1, 2, because that's my base. All right. That 2 could change all the time, depending on what it is. All right. So that's my parent function. I could have a lot of parent functions here, but this is going to give me my 2 points, and then the transformations of how I'm going to change those 2 points. Okay. All right. So here we go. The first one that we have here, I have f of x equals 3 to the x minus 2. What transformations do you see on that one?
Isn't it left two?
Not left 2, but
Right.
right 2. Yeah. So this is right 2. And that's technically the only transformation that I have. You go, well, what about the 3? The 3 is my parent function. 3 is my base. So what 2 points do I know right now?
1, 0, 1,
0, 1.
0, 1, and
1, 3.
1 in the base, which is 3. Okay? So 0, 1, and 1 in the base is where I'm going to start because of that 3, that's the base. Now, I'm going to kind of graph them lightly. So 0, 1, and 1, 3 would be right there. But they're not going to stay there because what am I doing? I'm going to move them right 2. So I'm going to move this one right 2. I'm going to move that one right 2. If I had my horizontal asymptote here at 0, if I move the horizontal asymptote right and left, does that change it? No, it's still going to be there. Okay? So there is a good graph right there. I can go in and sketch it. Domain would be all real numbers. Range would be y is greater than 0. So is my asymptote. Okay? I'm going to ask an additional question on this one because it's changed a little bit here. What's my y-intercept?
Between 0 and 1.
Okay, it's somewhere between 0 and 1. It's a fraction. I can see it right there, correct? Normally my asymptote's been 0, 1, right? But we moved it, this case. How can you find a y-intercept?
You just plug in 0, so it's
Plug in 0. So it's 3 to the negative 2.
so 1/9.
So 1/9. So 3 to the negative 2. 3 squared is 9, but it's 9 in the wrong spot. Put it on the bottom. So this right there is 0, 1/9. That would be my y-intercept. Everybody okay with how I got that? I hadn't done that in the other ones because it was always 0, 1. I hadn't moved it yet. Okay?
So you would,
I plugged 0 in so I could find my y-intercept. Okay? All right, let's go to the next one. F of x equals 1/3 to the x minus 4. Okay? See if you can sketch that real quick. Yeah.
Let's play Clash on this computer.
All right. What are the transformations in this problem?
down 4.
Down 4. Good. It's not in the print. It's not in the exponent. So down 4. What 2 points am I going to use to start this one?
0, 1, 1/3.
0, 1, and 1 and 1/3. Now, while ago we used a different one. We used -1, -3. You could use that as -1, 3. Excuse me. That would be fine. So if I'm lightly plotting these, 0, 1, 1 and 1/3. You could do -1 and 3, that's fine. But those are the final spots on those. What am I going to do with all those? Down 4. So each of those is going to be moved down 4. So down 4 here, down 4 there, down 4. What else moved? Asymptote. The asymptote was right here at 0. But if I'm moving the entire graph down 4, then the asymptote is going to move down 4. So there's where my asymptote now is. Wish we could do that on our papers, right? Okay? And so here is that graph right there. Right? What's the domain? Still all real numbers. What's the range? It changed, didn't it? This is the first time that we've seen the range change when we're doing this today. Why? Because we moved the asymptote. Okay? The asymptote is at y equals -4. One last one on this one. What's my y-intercept? Zero, -3. I could see it right there. The other thing is this. What is 1/3 to the 0 power? 1. minus 4 is -3. Okay? Alright, last one. I want to do one more with you and we'll be done. I want to do this one right here. I'm going to write it over here to the side. F of x equals e to the x minus 4 plus 1. What are the transformations? Up 1 and what?
Right 4.
Right 4.
Is that a negative or a positive?
It's a negative. Alright, up 1, right 4. What are my 2 points that I'm going to use?
I was looking at the left one.
0, 1, and 1e, which would be 2.718. So 1 and 2.718. Alright, now, not done. I'm going to apply my transformations. So I'm going to go right 4, up 1. I'm going to go right 4 and up 1. Now, many people will do that. They'll have the points in the correct spot. And they won't move the asymptote. Okay? And so they'll leave the asymptote at 0. Move your asymptote up to 1. And then there is that graph right there. Okay? Domain is all real numbers. Range is y is greater than 1. Asymptote is not y equals 0, but y equals 1. Could you tell me the y-intercept? Plug 0 in, right? If it was a non-calculator test, that's what it would be. Doesn't look very pretty, does it? No, just leave it. Don't try to worry about multiplying 2.78 by anything. All right? Just leave it as e squared or e to the 4th or whatever the case may be. If they really wanted to know the answer to that, you'd have the calculator. You can plug that in. Okay? All right. We've got about 4 minutes remaining. All right? We're doing page 404 for homework. Question number 1, all you're doing is you're looking at it, the problem, and tell me if it's growth or decay. Should be pretty quick. All right? Second one is I'm matching. There's a couple graphs, you're matching them to the equations. Third one, you got to do a couple sketches, and then I think it skips to number 6, and you're doing like a little word problem with it as you go. 404.